Good morning, kids. Today I'm going to talk to you about extreme values and critical points and how to sketch a curve. We've sort of talked about this type of thing before with regard to derivatives, but now we're really going to get down to the nitty gritty. All right, so first of all, we're going to talk about a critical number of a function. To find the critical number of a function, what we do is we take its derivative and we set it equal to 0. Or we find a place where its derivative is undefined. That's called the critical number, the x value that happens when the derivative is either equal to 0 or undefined. Now, there's another portion of this. If you make a point out of that, if you go back to the original function and you plug your x value that you get into the original function to get a y value, and you get a point, well then that's called a critical point. And critical points on a graph of a function are places where the graph has either a top, a maximum, or a bottom, a minimum, or a vertical tangent line. Okay, so those three things, or it can also have like a little plateau. It's a place where the slope is 0, basically. So a function will always have what's called an absolute minimum and an absolute maximum value over a certain interval from a to b. Now what that means is if you graph a function between two numbers, okay, what will happen is there's always going to be an absolute highest point or max on that graph, and there always will be an absolute lowest point or min on that graph. Okay, as long as you're graphing between two numbers, you're always going to be able to find a highest and a lowest point. All right, now sometimes there might be 2 points that are the same that are the highest point, or 2 points the same that are the lowest point, but they still both count as absolute maximum values or minimum values. All right, so where do these things occur? Well, they can occur at the endpoints, like in this picture. The absolute minimum value of this function between these two numbers happens right here. That's the lowest point on the graph. They can also occur at x values where the derivative is equal to 0, or the critical points. This one, the absolute max, the highest point on the whole graph, occurs at a critical point. And then it also can occur at x values where f prime of x is undefined. All right, another way to say critical point. So that's how where they can occur. To find these things is very simple. You find all the critical points of the function, you find the endpoints over your interval, and then you plug all of those into the function. And you take the largest and the smallest of those values. I'm talking about y values. When I talk about largest and smallest, maxes and mins, we're talking about the coordinates that have the highest and lowest y values. So here are some pictures of absolute maximums and minimums. Here is something that's defined over an interval, right? Here is this would be the absolute maximum over this interval. This would be the absolute minimum because they are the highest and lowest points. Here, this function, the absolute maximum occurs here at its highest point, and the absolute minimum over here at its lowest point. This one doesn't even have any critical points, but it still has a max and a min. I'm having a hard time today seeing my tablet because I'm holding Mary. She's got kind of a tummy ache, so she doesn't want me to put her down. So this is my first lecture I've ever done with a child sleeping on me at my kitchen table. It's one for the history books for sure. Next one, the next one, you're looking for a maximum at an interior point. If you see this one, you have a maximum here, and the minimum of this is at one of the endpoints. So it can happen any way. You're just looking, remember, the maximum is the highest y value, and the minimum is the point with the lowest y value, whether it be a critical point or an endpoint. In this interval, the minimum is at a critical point, and the maximum is at an end point. Moving on, I mean, there's so many different ways to look at this. Now, if you look at a discontinuous function, this discontinuous function has two absolute minimums, but it has no absolute maximum. All right, because there is no highest value on the interval. You can't pick something. It can't be 1 because it's discontinuous at 1. So even a single point of discontinuity can keep a function from having either a maximum or a minimum value on a closed interval. Alright, so that's that. And then let's talk about local versus absolute. Now, if you talk about local, if I talk about going to the local restaurants, you're going to go to the restaurants that are nearby. For you in Carthage, the local restaurants would be, well, geez, there's not a lot of restaurants in Carthage, but there's the Superior, there's Stefano's, geez, I can't think of any other restaurants. I'm sorry if I'm leaving a bunch out, but that's all I can think of right now. So, anyways, those are local, close by, okay? When we talk about local maximums and local minimums, we're talking about the highest and lowest points in the area, okay? So, for example, this is a local maximum. This is also a local maximum. This is a local minimum because it's lower than all the points around it. This is a local minimum because it's lower than all the points around it. And this is a local minimum because it's lower than all the points around it. Okay, so let me circle the minimums in a different color than I did the maximums to make it a little clearer. Okay, so here are the local minimums because they are lower than all the points around them. Here in pink are the local maximums because they are higher than all the points around them. All right, so if you have these things, that's fine, that's local. Now, you can also find the absolute. As long as you have a closed interval, you can find the absolute highest point in the interval and the absolute lowest. The absolute maximum for this interval is the highest point, which occurs here, right? Absolute max occurs, whoops, wrong color. Absolute max occurs here. Absolute min occurs over here, all right, because it's the lowest point on the whole interval. All right, so if you wanted to pause the video right now, you are now prepared to do part 1 of the homework, okay, which is on page 181 to 182, 1 through 13 odd, 31, and 33, okay? You can do those based on what we just did. I am going to now go on to part 2 of the notes, which goes with the worksheet that you're going to get today. Mrs. Haney will pass out this worksheet on critical points and curve sketching, and the notes I give you today will help you with this worksheet. All right, so I'm going to continue, although you may have paused the video to do those problems on 181 to 182. All right, so let's go on. Now I'm going to talk a little about graphing again. At a critical point where the slope is equal to 0, or where the derivative is equal to 0, there is a horizontal tangent line to the graph of f. So the critical points in this graph are A, B, C, D, E, and F. All of them are horizontal tangent lines, places where the graph goes flat. Now, the great majority of horizontal tangent lines will produce maximums and minimums, all right? So which ones of those are local maximums? Okay, now notice I say local now because this graph goes on forever in this direction going up. It also goes on forever in this direction going down, all right? So you have a graph that continues in both directions. So I'm going to hand Hold on, folks. I'm going to hand Mary over to her daddy now. He seems to be here. Oh, there we go. Mary's daddy is going to be in the Donegal Beard competition at the Irish Festival, and so today he has this big puffy beard and no mustache, so he's looking very Irish at the moment. Anyhow, getting back to the point, the critical point I should say, if you look at this picture now, the local maximums in this picture would occur at, what color did I use for maximums in the other one? Pink, okay. Might as well stick with pink. The local maximums in this picture occur at B and C, right? Because those are the points where the graph has a top, okay? And then the local minimums in this picture occur at A and at E. D and F are plateaus, all right? They are critical points, but they are neither maxes nor mins, all right? So remember also when we're doing these types of problems that if the derivative is positive, that means the slope is positive and the graph is increasing. If the derivative is negative, then the slope is negative and the graph is decreasing. All right, so let's move on. I'm going to show you how to find the critical points of this function in example number 1. So step 1, find f prime of x. Very simple derivative to take here. F prime of x is equal to 3x squared minus 18x minus 48. Set f prime of x equal to 0 and solve for x. So now I'm going to take that f prime of x that I just got and I'm going to set it equal to 0 and solve for x. Now this is something, you've done this before, right? So we factor out the 3, we have x squared minus 6x minus 16 equals 0, and then we can go ahead and factor that. X minus 8 times x plus 2, and then finally we will go ahead and set each part equal to 0. Okay, so 3 is never going to equal 0, so we just cross that right out. X minus 8 equals 0, that means x equals 8. X plus 2 equals 0, that means x equals negative 2. So these are called the critical numbers. To get the critical points, we have to plug back into f of x to find the y values. Notice we're plugging back into f of x, not f prime of x. If we plug back into f prime of x, we're going to get 0. Because we just set f prime of x equal to 0 to get those numbers, right? We need to go back to the original function and plug in. So we're going to find f of 8 and f of negative 2. So f of 8 is equal to 8 cubed minus 9 times 8 squared minus 48 times 8 plus 52, which is negative 396. F of negative 2 is equal to negative 2 cubed minus 9 times negative 2 squared minus 48 times negative 2. And of course your calculator will do this all for you, plus 52. And that equals 104. Now if you put your f of x function, your original function, into your calculator and go to the table, set up your table so that it asks you for values and plug in 8 and negative 2, then the y values it will spit out will be negative 396 and 104. Okay, so our points are 8, negative 396, and negative 2, 104. So once we have those values, we've found the critical points, which is all we had to do for this particular problem. The next problem is a little more complicated. Let me show you on the worksheet. Worksheet numbers 1 through 4, 5, 6, 1 through 7 are all just finding the critical points. You don't have to graph, you just find the critical points. If you look at number 3 on the worksheet, just very quickly, when you take the derivative of this using the chain rule, you get 6 times x squared minus 4 to the 5th times 2x. Now, if you get that, then x squared minus 4 to the 5th is basically the same factors 5 times, right? So this is 12x times x plus 2 times x minus 2 to the 5th power. Now, if you want to write that x plus 2, x minus 2 5 times, that's fine with me, but it doesn't matter how many times you write it. The answers that you will get out of that will still be x equals negative 2 and x equals 2. And whenever you get a factor of x in front of your parentheses, whether it has a variable in front of it, no matter what power of x it is, if that factor of x is in front of your parentheses, then that yields x equals 0. All right? Not a number, but if you actually get a factor of x in front of your parentheses, then that will yield x equals 0, because you'll be setting that equal to 0 and dividing by the constant. All right, so these are your x values. I've pretty much done that problem for you. All you have to do is find the y values. The other thing I wanted to draw your attention to is number 4. It says minus plus 4. It should just say minus 4 on the worksheet. Oops. So this should read x to the 4th. Oh, I crossed it out so I can't see it now. Minus 5x squared minus 4. All right. And don't forget, when you're doing these problems, that you can take out a common factor sometimes. You always want to look for a common factor first when you're factoring. All right, so let's move on to the last part of the last problem on the notes, which is curve sketching. So use the derivative to graph the function and identify any local or absolute maximum or minimum values. So first thing we're going to do, find f prime of x. So if f of x is equal to this, then f prime of x is equal to 4x to the 3rd minus 12x squared. And then the constant, of course, the derivative of a constant is 0. Now we're going to set this equal to 0 and solve for x. So we get 4x to the 3rd minus 12x squared equals 0. And we will factor out what we can factor out. So here we can factor out a 4, and we can also factor out an x squared. So we have 4x squared times x minus 3. Setting each factor equal to 0, we get 4x squared equals 0, which means that x equals 0. And then we get x minus 3 equals 0, which means that x equals 3. Next step, find the y coordinates of each point from step 2 by plugging into f of x. Use your calculator if you need to. All right? So remember, this is plugging into the original function. That is probably the most important thing to remember. To get your y coordinates, you plug into the original function. So we have f of 0 is equal to 0 to the 4th minus 4 times 0 to the 3rd plus 15, which is equal to 15. So one of our points is 0, 15. The other point, f of 3, is equal to 3 to the 4th minus 4 times 3 to the 3rd plus 15, which is equal to negative 12. So next point, 3, negative 12. So those are the only 2 points we have. So well, now when we go to do our actual graph, we're going to do it down here. All right, so we've got 2 points already on our actual graph. We have 0, 15, so this is a guesstimate thing. Just label it label 0, 15, and then put 3, negative 12 somewhere to the right of that, and not quite so far down on the other axis. You don't need to do this on actual graph paper. This is a sketch. Alright, so if 15 is here, then 12 wouldn't be quite so far out, and then 3 we'll put out this way just to make it a little easier on us. So we'll call this 3, negative 12. So those are our 2 points. Alright, so this is 0, this is 3. Those are our only 2 critical points. Those are the only places that our graph could possibly change direction. Okay, so there's not a lot that can happen here on this graph. We're going to graph f of x, but we need to figure out what the slope is between before and after those points. To find the slope, we're going to plug those x values, just the x values, into the derivative function. So up here, I'm going to do an f prime number line. And the only 2 points I need on it are x equals 0 and x equals 3. And notice I put them in the exact same locations on this number line that they are on this line down here, so that I can just look up and see if my graph is going up or down by just looking at those at this graph up above. So we're plugging now all the values between before and after 0 and 3 into f prime. Now we've done this before, right? So this, to find increasing, decreasing, concave up and concave down. Same thing we're doing here. We're trying to figure out if this is increasing or decreasing. So pick a number to the left of 0, and we're going to plug that number into f prime. Now, if you've forgotten what f prime is, the most factored form of f prime is the one we want. So the most factored form of f prime of x is equal to 4x squared times x minus 3. Okay, so 4x squared is always positive, so that's not going to impact the sign of this in any way. So all you really have to do is see if the number makes x minus 3 positive or negative, because 4x squared is a positive. So pick something to the left of 0, and we get, for example, negative 5. If you put a negative 5 into 4x squared, as I said, that's going to be positive. If you put a negative 5 into x minus 3, that's negative. A positive times a negative gives me a negative. That means all through here, my graph of f prime is decreasing. So right before I get to 0, my graph of f prime is decreasing. At 0, I know I have a flat spot, right? I have a flat spot at 0. Don't forget that. That's why it is 0. That's why the derivative is 0 there, is because you have that flat point there. And then after 0, pick a number to plug in. Make sure it's before 3. So pick 1. I love 1. Plug 1 into 4x squared, you get a positive. Plug 1 into x minus 3, you get a negative. So that's another positive times a negative, which is a negative. So it's still decreasing here. Okay, very, very important to note that you don't have to get a sign change there. So this is a situation where it's going to go down, it's going to flatten out, and it's going to go down again after that. Okay, so what's happening here is we end up with what we could call a plateau at that spot. You see it? All right, so then at 3, remember you're decreasing just before 3, because this is a negative slope. See what happens after 3. Plug a 4 in. If I plug a 4 into the 4x squared, I get a positive. 4 minus 3 also gives me a positive. 2 positives give me a positive. So after 3, my graph is increasing. Okay, so I flatten out again at 3, and then after 3, I'm increasing. So there I have a bottom or a minimum. Okay, so this is the point 0, 15. This is the point 3, negative 12. Right? So at 0, 15, I have a plateau. At 3, negative 12, I have a minimum. So I can draw those in right now. I'm going to draw myself a plateau at 0, 15. You know there's not going to be any other sign changes other than the ones we've determined. So let me make a pretty plateau at 0, 15 here. Do the best I can. I'll do it a different color as well so you'll see it well. So this is a plateau. So it's flat there, goes down afterwards, and is going down before. Remember, when I say down, when I say the slope is decreasing, that's from left to right. You always have to read from left to right. All right, so we have that. I still don't like exactly what my graph is doing, so I'm going to make it a little bit better. And then when I get down to 3, I have to have a bottom there. All right, so put that in. Connect the dots. You've got a plateau, and you have a bottom. And that's it. You've got your graph. So as long as you get the basic shape of your curve, you're all set. So 0, 15 is a plateau. 3, negative 12 is a minimum. Now, in this particular graph, by the way, since both of these arrows are going up, not only is this a local minimum, it is also an absolute minimum. Why? Because there are no other points on this graph that are ever going to be lower than that point. All right, so that is the entire lecture. Of course, we need to label our graph here. F of x is equal to x to the 4th minus 4x cubed plus 15. We have our points labeled. And that's it, kids. So hopefully that helps you with the curve sketching portion of the worksheet. Good luck with that. I believe I've already posted all the answers online, so if you need a hint, you can go there. Have a marvelous day.